Okay, let's talk through this thought experiment really quick. So, if I have two identical bullets, okay, and I load one of those bullets into a gun and I point that gun perfectly horizontal with the ground, like completely parallel. I'm not pointing up, I'm not pointing down, okay? And then I take the second bullet and I hold it, I'll switch hands so you can see it a little bit better. I hold it at the height of the barrel of the gun, okay? And then simultaneously, I shoot the gun and I drop the bullet. So here's the question. Which bullet will hit the ground first? The one that was shot out of the gun or the one that was dropped from the same height as the muzzle? Right? Now, what we're not arguing over is the X direction, right? Obviously, the bullet that was fired from the gun will travel further in the X direction than the one that was just dropped. But what about the Y? We know that if the gun is pointed perfectly horizontal, it's parallel to the ground, then that must mean that the initial velocity of the bullet is all in the X direction and none of it is in the Y. So the initial velocity of the bullet in the Y is 0. And then gravity will pull on it and we'll see an acceleration, right? But what about the one that we dropped? Same thing. The initial velocity would be 0, and then gravity pulling on it will get that acceleration due to gravity. And so as far as the Y direction goes, they will hit the ground in the same amount of time. The bullet that we let go will hit the ground at the exact same time as the bullet that was shot from the gun. Okay? So let's take that information, let's use it with this problem. We want to know what the initial velocity is in the Y, but the entire initial velocity is in the X direction. So that must mean the initial velocity in the Y is 0. Okay, so it's just like dropping the bullet versus firing the bullet. Okay, we don't know what that final velocity is, and the acceleration is due to gravity. We don't know the time component. Okay, so let's see if we can focus a little bit better for us. Yeah, okay. So part A, we want to know how long does it take for the stone to reach the bottom of the cliff. Okay. We want to know the time final. Now, something that you should keep in mind, we have two equations here. It's this one and this one. So for those two, they do not work if the acceleration is equal to 0, okay? So star means that we can't use these equations if acceleration is 0. Okay, and here's why. If the acceleration is 0, that means velocity initial and final are the same. So if I have velocity final and I minus the initial, which is the same amount, then those components drop out. And not only that, our acceleration is 0, so this component would drop out as well. And we have the exact same problem down here. Is if this velocity final is the same as the initial, well, when I subtract that over, they cancel, and then this acceleration is 0, so that component goes to 0 as well. So we're not left with an equation that we can use. Okay. So in the Y though, we do have an acceleration, so we can use any of them except for this one. Okay, because that one is only if the acceleration is 0. And so we want to find time final. We need to pick an equation that does not have velocity final in the Y because we don't know that information. So we can't use this one. We could use this one. We can't use that one, and we can't use that one. Okay. So let's use that equation there. So keep your work really organized. We'll say we want to know time. So here's our Y component of work. Now these equations all say X, but we can change it to Y. So we can say Y final is equal to Y initial plus velocity initial Y multiplied by T final plus 1/2 acceleration T final squared. Okay. And let's look at our list here. y final, that's equal to 0. And velocity initial, that is equal to 0. Anything multiplied by 0 is 0. So this t final, even though, that's the component what we're looking for, it's multiplied by 0, so this whole thing becomes 0. So if I were to rewrite this equation, I would say 0 is equal to y initial plus 1/2 acceleration t final squared. Now I'm going to rearrange this equation to solve for time. So I'm going to subtract y initial, and then that'll set that equal to 1/2 acceleration t final squared. So I'll divide by the 1/2 in the acceleration. So I'll have negative y initial divided by 1/2 acceleration equals t final squared, right? And so I'm going to take the square root of both sides. Okay. So now we're just plugging in those numbers. Let's see. Okay. So what we're doing is we're going to take the square root. Okay. The square root, so I'm trying to find a place where you can see the equation and you can see the calculator, of a negative y initial, and y initial, so I'm going to put another parentheses, negative y initial. Y initial was 78.4, and then we're dividing that by 1/2, or 0.5, times by a negative 9.81, because that's our acceleration. Okay. And so we have 3.9 time final. Let's see, we have 3 sig figs, so 3.99, which will round up. Show you what I mean. Here's my 3 sig figs, but then the 7 rounds everything up from there, so we round up to 4.00. Okay, so that was part A, running out of space. So part A, how long did it take the stone to reach the bottom of the cliff? 4 seconds. B, how far from the base of the cliff does the stone hit the ground? How far from the base of the cliff? Wouldn't that be our x final, right? If this is x initial, that would be x final, and that's the distance from the base of the cliff. So I'm going to start working in the x direction. And I know my time component now, right? I could plug that in. It's 4 seconds, and it's the same for both. So I need to pick an equation. The acceleration is 0, so I cannot use this one or that one. I need to pick an equation that I have x final, right? So I can use this or this. That's the delta, so it's x final minus x initial. This is already solved for what I'm looking for, so I think I'm going to choose that equation. So x final equals x initial plus velocity initial in the x, t final, 1/2 acceleration t final squared. Acceleration is 0, x initial is 0. Okay? And so that would mean that our x final is equal to velocity initial in the x direction multiplied by t final. And we have all that information. We know what the initial velocity is, and we know what the time is. So we'll have initial velocity of 5 meters per second multiplied by 4 seconds. This was 2 sig figs, so we'd have 20 meters. Okay, so there's B. There's A, there's B. C. What are the horizontal and vertical components of the stone's velocity just before it hits the ground? So we want to know the vertical and the horizontal. The vertical would be the y component, the horizontal would be the x. We want to know the final velocity of the horizontal. Well, we already have that. So I'll put box around that. And that's part C. And then we want to know this vertical component as well. So let's pick an equation where we're looking for this velocity final. That one's already solved for it. This one would be really simple, especially since the velocity initial is 0, so that component would drop out. And this delta t is just final minus initial, and initial is always 0. So really, we could change that delta t to be t final. Okay, and so this last component here in the y, velocity final equals velocity initial plus acceleration times by t final. That's 0. So velocity final equals acceleration times by t. Oh, sorry, I got those mixed up. Oh yes, we're looking in the y. That's my bad. So yes, so the y initial is 0. Y, if I'd put the little y's on there, then I would have been able to keep track of that. Keep your work organized. So it's going to equal acceleration times by time. Okay? So I'm going to plug that in. We know that the acceleration is a negative 9.81, and we know that the time is 4 seconds. So negative 9.81 times by 4 seconds. I'm working with 3 sig figs here. Negative 39.2 meters per second. Let's see. And that should make sense, the negative sign, I mean, because in the y direction, the velocity is going down when it hits the ground. Okay, so that was example number 1. Lots of great info there. What I want you to do is I want you to go through and see how far you can get with example number 2, and then come back and follow along and see what you're missing. Let's just quickly draw the picture and establish the origin though. So Millie got a part-time job working at an assembly plant making toy Star Wars figures. At the end of the assembly line, the toy figures go horizontally off the edge of a conveyor belt and fall into a shipping box below. The box is 0.6 meters below and 0.4 meters away from the end of the belt. Okay, so we have this conveyor belt, right? And we have toys coming off of the conveyor belt. They're gonna fall down and they're landing inside a box. Okay, and this box is 0.6 meters below, so that means this distance here is 0.6 meters, and it is 0.4 meters away from the end. We should space it in here, so that is 0.4 meters. Okay, so there's my image, and I'm going to choose the base of where it's coming off right there. That's going to be my origin. That's going to be my 0, 0 point. Okay, guys, go ahead, list what you know and what you don't know, and then use your equation, see how far you can get on that.